Now, after group 2, as I just said, the next or the third chapter in inorganic chemistry is group 7 elements. Group 7 ko for last 3-4 years we are also calling it group 17. तो आप इसको group 7 बोलें, group 17 बोलें, it's same thing. Chemistry does not change about the title of the group. In fact, why do we call it group 17? Like some of the groups that we don't count in between, like the 10 transition elements. So, we have group 1 here, 2, and then we start with 3, 4, 5, 6, and up to 8. So what Cambridge has done is like there are 10 groups in between. जो transition elements के इधर हैं ये 10 हैं. So they've just continued the counting downward here. तो 1, 2 के बाद 3, 4, 5, 6, 7, 8. तो technically जो 3 है वो 13 बन गया. 4, 14. Group 7 becomes 17. So in short, just remember group 7, 17 or group 3 or 13, like in P block. Just add 10 in that to count transition elements, 10 groups in between. लेकिन ये चीज इन्होंने की तो है कैम्ब्रिज ने, लेकिन केमिस्ट्री के हिसाब से ग्रुपिंग इज नॉट दैट वे. सो विल जस्ट consider group 7 or 17 same for the time being at least. Ab group 7, as the name shows, is all about halogens. We call group 7 elements halogens. And halogens, word halo means salt, not the one that we say on the phone, but this word halo in Latin means salt. Gen means generator, salt generator. So these elements of group 7, they make common salts. Like the most common salt is this NaCl, rock salt, which is हम कहते हैं. So because NaCl is made by group 7 element, so such elements which make the common salts that we use are called halogens. That's like the worldly meaning of group 7 elements, halogen word. तो अब इसमें जो एलिमेंट्स हैं आप लोग IGCSE से पढ़ रहे हैं, विल जस्ट लिस्ट देम अगेन और उनकी भी कुछ प्रॉपर्टीज लिखेंगे. सो ट्राई एंड कॉपी दीज थिंग्स फास्ट विद मी बिकॉज देयर इजी स्टफ, कोई कॉम्प्लिकेटेड कॉन्सेप्ट नहीं है. फिर मैं नेक्स्ट स्लाइड पे जाऊंगा. सो वी गॉट फ्लोरीन, क्लोरीन, ब्रोमीन, आयोडीन एंड one last is astatine. We normally don't talk about astatine, but you'll see it in the questions.
अस्सलाम वालेकुम सर.
वालेकुम सलाम. एस्टेटीन को भी हम साथ ही डिस्कस करेंगे. So again, as if we list some of the properties of group 7 elements towards astatine, including atomic size, ionic or ionic size or ionic radius, pair, melting point, that's an important one, and reactivity, and then oxidizing power. Oxidizing power or oxidizing ability. इनको हम मिलके डिस्कस करते हैं. The difficult ones I'll fill myself, like atomic size increases. Ionic size would also increase down the group because they all become one negative when they gain electron. तो सबका size same ratio से increase होगा. And reactivity of halogens decreases down the group. Now I've completed the difficult ones. Easy ones मैंने आपके लिए छोड़े. जरा बताओ ना मुझे. Melting point down the group, halogens का increase, decrease.
Increase. Increase.
Increase होगा. Good, शाबाश. अगर भूल भी जाए तो just recall the state of these halogens. I mean, fluorine, chlorine are gases at room temperature, and bromine is liquid. That's the only non-metal which is liquid at room temperature, and astatine and iodine are solid. So if I'm changing something from gas to solid, we expect its melting point to increase. लेकिन इसमें आपने ये नहीं सोचना कि when we melt or boil these elements तो इनके कोई strong covalent bonds break होंगे. It's the intermolecular forces which break between these molecules. So fluorine की fluorine से, for example, और chlorine की chlorine से जो intermolecular force है, can you people try and tell me what force of interaction would that be? ये वाली.
TID.
शाबाश, अब आप लोगों को समझ आ गई है. तो टीआईडी भी ब्रेक होती है. अब टीआईडी पे इंटरमोलिकुलर फोर्सेस सेम है, तो इट मींस के फिर आपने एमआर पे डिसाइड करना है. व्हेन एमआर इंक्रीजेस डाउनवर्ड, तो फिर नेचुरली then melting points will increase, but don't consider breaking the covalent bonds when you melt these compounds. In fact, that takes quite a high amount of heat or energy, but that's even a chemical change. Melting is a physical change. ऑक्सीडाइजिंग पावर, मैं आपको हेल्प करता हूँ, आप लोगों ने फिर गेस करना है. ऑक्सीडाइजिंग पावर इज एक्चुअली द एबिलिटी टू गेन इलेक्ट्रॉन.
Decreases.
एबिलिटी टू गेन इलेक्ट्रॉन. हाँ, तो इन हैलोजेंस की जो दे ऑल गेन इलेक्ट्रॉन व्हेन दे रिएक्ट, दे ऑल बिकम नेगेटिव आयन. सो देयर एबिलिटी टू गेन इलेक्ट्रॉन डिक्रीजेस डाउनवर्ड्स. सेम क्यों? ये क्या बात है? इनफैक्ट ऑक्सीडाइजिंग पावर लिंक टू द रिएक्टिविटी. इन सारों ने इलेक्ट्रॉन गेन करना है ना, तो आई मीन फ्लोरीन विल गेन इलेक्ट्रॉन फास्टेस्ट from anything else compared to iodine or astatine. So the ability to gain electron becomes less and less as they go down. They all gain one electron. That's for sure. Obviously, हम इस सेंस में इसको नहीं कह रहे. हम ये कह रहे हैं कि अगर मेरे पास इधर फ्लोरीन एटम है and एक इलेक्ट्रॉन पड़ा है, और फिर इधर आयोडीन एटम है and there is this one electron there. So fluorine will gain that electron much faster. We studied that the electronegativity of fluorine is highest even. That is its power to draw electrons. तो नेचुरली वो जब ज्यादा है तो फिर इसकी ऑक्सीडाइजिंग पावर भी ज्यादा है. So this is like the introduction of group 7 elements. These kind of things come in MCQs. तो वो मैंने इधर लिख दिए हैं. इनमें कोई क्वेश्चन है तो आप पूछें, आसान है सारा. अब इसके बाद next we have reactions of group 7 elements. We got 4 reactions and 2 of them are really important. I mean, उसमें अगर आप group 7 elements के past paper solve करें, so about 50% of questions are asked from those 2 reactions only. So अब उसके लिए I'll go on the next slide now. I couldn't share class yesterday's recording, तो वो और ये वाली मैं आज एक साथ share कर दूंगा. But because this topic is entirely different from what we done yesterday, तो जिन लोगों ने नहीं भी देखी तो कोई मसला नहीं. Both are separate topics. So next is reactions of group 7 or group 17 elements, halogens. The first one is reaction with hydrogen gas. So all these group 7 elements react with hydrogen to make hydrogen halides. But what do we need to show in this reaction? In सारे reactions की कोई background है किसी वजह से आपके syllabus में, you need to understand that reason also. So reaction with hydrogen shows reactivity. जो भी हमने लिखा ना, down the group decreases. तो इससे हमें group 7 elements की reactivity का trend पता चलता है. Like when I react hydrogen with fluorine, it would form hydrogen fluoride too. All of them are like gases here. This reaction is violent reaction, very fast. It's like extremely fast reaction. Even in dark or in cold. Now we know group 7 elements get triggered by light, UV light say. Lekin fluorine, because it's most reactive non-metal, it reacts violently with hydrogen, even if we keep it in dark and in cold. So this shows how reactive fluorine is. But when it goes to chlorine, the product will be same, 2HCl, gaseous, balanced, same moles and all, gas and gas. But this reaction needs UV light. So it's a fast reaction, but needs UV light. It won't happen in dark or and very low temperature. तो इसको बस room temperature पे you give UV light, so it will be happening quite fast. Then hydrogen reacts with bromine, but that one is not a very fast reaction. So this reaction needs heat. I mean, ये थोड़ा heat करें तो होता है, else it doesn't happen. Now this thing tells me clearly bromine तो खैर liquid है, but product because it gives out heat at time. So HBr stays in gaseous form. We prefer it that way. This shows me clearly that bromine is much less reactive than chlorine and fluorine, obviously, because their reactions, fluorine's reaction was happening violently even in dark and cold. Chlorine
So
को
this
heat,
is an endothermic reaction.
generally endothermic as in थोड़ी इसको हमें slight heating करनी पड़ती है, but once this reaction starts, so it gives out heat and that makes HBr to go gaseous.
Okay, sir.
अच्छा, अब आयोडीन का जो रिएक्शन है इट इज एक्सट्रीमली स्लो, इनफैक्ट इट्स अ रिवर्सिबल रिएक्शन. आयोडीन की इक्वेशन जब आप लिखेंगे विल पुट रिवर्सिबल एरो and it makes 2HI, gas, gas and gas. So this tells me that this reaction is reversible and it's very slow, needs high heat. अब देखें एक साइड पे फ्लोरीन है, उसको आप डार्क में भी रखें, कोल्ड रखें, still it reacts violently, and when it comes down to iodine the reaction becomes reversible. So when a reaction becomes reversible, it means the product is not stable. I mean product जो है वो वापस टूटता रहता है, break down हो जाता है. So it clearly shows that as we go down the group, the reactivity of halogens decreases. अच्छा, आप देखें syllabus में we have reactions till iodine, but what examiner does is they pick up the concept from syllabus and they want you to apply it to a concept or reaction which you have not studied because it was not again in syllabus. वहाँ हम सोच expect करते हैं कि students in A level should be able to apply themselves and try and answer that. तो उस basis पे again this sort of sign which I put with inorganic chemistry means this thing is not in syllabus as such. They won't ask you entire blank question on it, but they'll give you some information and then ask. That is, if hydrogen reacts with astatine, astatine is 82. So could you people try and tell me the product formed? जी बेटा, product क्या होना चाहिए? Formula of the product?
HAT.
Hydrogen acetate. Just like all the other halogen halides, the formula does not change. And anyone else could tell me that the sign between the reactant and product, should it be irreversible or reversible?
Reversible.
This would also be reversible. Good. And then if you're asked to compare the reaction of astatine with hydrogen with iodine and hydrogen, so what would you write? Astatine's reaction with hydrogen would be slower than iodine, right? क्योंकि एस्टेटीन आयोडीन से भी नीचे, अगर आयोडीन इतना पुअर रिएक्ट कर रहा है तो एस्टेटीन तो और भी मुश्किल से करेगा. And astatine gives slowest reaction among all in all the halogens. तो ये आ चुका है पेपर में, but again as I said कि this is not something where a student takes hard line के सर ने कहा था ये तो सिलेबस में नहीं और आ गया. अगर आप ये सोचना शुरू हो जाए पेपर में, फिर वो क्वेश्चन आपके लिए नहीं है. Otherwise such questions are easiest in fact because they need some concept and then you apply that only.
Would acetylene need a catalyst?
No, we don't need a catalyst here. We just need to heat it more than iodine and yes, it's like very slow reaction.
Sir,
जी.
I2 and 82 will not be solid.
नहीं बेटा, इस रिएक्शन को हम हीट कर रहे हैं ना, तो जब आप हीट करोगे, हमने आयोडीन सॉलिड्स में पढ़ा था कि आयोडीन सब्लाइम्स ऑन हीटिंग, तो आप हीट करेंगे तो रिएक्शन होगा, और सॉलिड स्टेट में तो इट डजंट एस्टैब्लिश इक्विलिब्रियम इवन. मैंने यहाँ रिवर्सिबल साइन लगाया है. So to establish equilibrium, iodine must be in vapors form. अच्छा, let's go on the
Sir, but
next.
why do,
Hmm.
can I ask something?
जी पूछो.
Why is the state of bromine liquid if we're also heating it?
We don't heat it that much. वही यही मैं बता रहा हूँ ना. ब्रोमीन वाला रिएक्शन जब आप करते हैं ना तो it's like you got bromine liquid and in a beaker, and bromine liquid already keeps on giving fumes even at room temperature, and we just pass hydrogen gas from it, and on the burner we just warm it or heat it slightly, and we try and not keep the temperature very high. So then it reacts, and the product formed because of heat, the product HBr goes out as gas. तो वैसे HBr रूम टेम्परेचर पे HBr तो लिक्विड है, HI सॉलिड है, HAT भी सॉलिड है, बट इन दीज रिएक्शंस बिकॉज दे आर गिविंग हीट इवेंचुअली, आप थोड़ा हीट करते हैं, जस्ट लाइक पेट्रोल को बर्न करें तो हीट करते हैं एक्टिवेशन के लिए, बट the reaction afterwards start giving out heat and that makes our product go gas. लेकिन हमारे पास जो reactant की state है bromine की, it is staying liquid. We have not turned it into gas. I mean, if I'll just carry out this reaction like this, H2Br2 और bromine को पहले मैं gas बना लूँ, तो फिर this reaction would be happening at room temperature because I've already converted bromine into gas, which has used all the activation energy required. तो हम उनको उनकी एक्चुअल रूम टेम्परेचर पे स्टेट में लेके रिएक्ट करवा रहे हैं.
Okay.
अब जो सेकंड रिएक्शन है ग्रुप 7 एलिमेंट्स का, दैट is with water. That reaction does not come too often, but I count it very important reaction. तो इसको आपने जरा सही से प्रिपेयर करना है. So second reaction is with water. Now reaction of halogens with water explains the oxidizing power of halogens. I mean, as I said, it's not about कि आप equations रट लें और सारा. आपको साथ उस reaction के और कोई significance है, the one that I'm mentioning, for example, the last one was to show reactivity of halogens with hydrogen. Reactivity compare करता है. This reaction compares the oxidizing power of halogens. Or oxidizing power again is the ability to gain electron. अब इसके लिए when fluorine is reacted with water, it forms hydrogen fluoride and oxygen gas. And you know, if we look at the oxidation states here, oxidation state के हिसाब से fluorine goes from 0 to -1 completely, and oxygen goes from -2 to 0. So fluorine has been reduced, gain of electron, and oxygen has been oxidized. So fluorine can oxidize oxygen completely and make these products. But when we react chlorine with water, you must remember this reaction from redox. And like when chlorine reacts with water, it makes hydrochloric acid and hydrogen chlorate. Because of water, they're all aqueous. अब इस reaction में chlorine is going from 0 to -1 in HCl and then from 0 to +1 in HClO. So you could say that half chlorine is reduced and half is oxidized. So it means chlorine cannot entirely oxidize water. जैसे fluorine ने कर दिया ना, this reaction is entirely a redox reaction, completely redox. But the second reaction is where chlorine is reduced and oxidized. Could you try and tell me the name of this reaction? हमने पढ़ा इससे पहले. Anyone? The second reaction.
Redox.
No, this one is not redox.
Sir, disproportionation.
Oh, good, excellent, Shahid. आपने तो ball stadium से बाहर फेंक दी. This reaction is disproportionation. Disproportionation reaction is where one element is reduced and oxidized simultaneously. So अगर आपको नहीं याद या हमसे कहीं मिस हुआ है इससे पहले, I don't remember doing that because redox में ये लाजमी मैं बताता हूँ, तो इसको लिख लें disproportionation and you need to write it's like reaction where same one element is reduced and oxidized. एक ही एलिमेंट प्रोडक्ट में जाके रिड्यूस भी हो रहा होता है और ऑक्सीडाइज भी हो रहा होता है. So we call it disproportionation reaction. That's like chlorine goes from 0 to -1 in HCl and then +1 in HClO. तो इसको हम बोलते हैं disproportionation. So this shows chlorine cannot entirely, oxidize water, and that's why the power of oxidizing or oxidation power of chlorine is less than fluorine. The next halogens like bromine, iodine, etc., they show no reaction with water. So as we go down from fluorine towards, iodine, bromine, etc., so the oxidizing power decreases. Oxidizing power.
बैठ ली तीनों जान से मार दूंगी सी والله quantum खाली सकते.
All right, so that was like second reaction of halogens. First one we done was with hydrogen. That shows the reactivity difference of halogens. Second reaction is with water. That shows oxidizing power of halogens. Only fluorine can oxidize water completely and form these products. Chlorine में 50% chlorine reduce हुआ और बाकी 50% oxidize हो गया यहाँ पे, which we call a disproportionation reaction. A disproportionation reaction is the one in which one element is reduced and oxidized simultaneously. Bromine, iodine don't react with water. They simply get ionized in water, partly ionized. So उसको हम chemical change नहीं count करते, and that means water is too strong for bromine, iodine to get oxidized against them. अच्छा, ये जो disproportionation है, इसमें there is one more example that is of chlorine with alkali. वो भी normally मैं इधर बताता हूँ. Sometime I teach it in moles. तो keeping the doubt, we'll just do it next. उसकी अलग से कोई साइड हेडिंग बनाने की जरूरत नहीं है, बट अगर आप बनाना चाह रहे हैं तो we can do that, like reaction of chlorine with alkali. तो I'll write that on next slide. इसको I hope आपने लिख लिया, otherwise I'll be sharing recordings. दोनों क्लासेस की रिकॉर्डिंग्स मैं अभी आज ही शेयर कर दूंगा. इस क्लास के बाद आई एम फ्री, उधर से फिर आप लिख लें. Now at number 3, we could add reaction of chlorine with NaOH. So when you were doing moles calculations, so there were some calculations of chlorine reaction with NaOH and all. तो वहाँ हमें इस reaction की जरूरत पड़ती है. तो then I said कि you'll be getting equation before you study this. So NaOH का chlorine से reaction happens in 2 different conditions. Like if you take NaOH in cold state, room temperature पे, like if I react chlorine with NaOH and it's like cold or room temperature, like we don't heat NaOH. This leads to formation of NaCl, NaClO plus water, and that will balance simply by putting 2 with NaOH. NaCl aqueous है, NaClO sodium chlorate aqueous है, water liquid. अच्छा, अब आप देखें chlorine's oxidation number goes from 0 to -1 in NaCl, and then it goes from 0 to +1 in NaClO. ठीक है, तो इधर ये हो रहा है reduce and यहाँ हो रहा है oxidize. So this reaction also is an example of disproportionation. अभी जो मैंने आपको term बताई, this is also an example of disproportionation.
सर हमने डिस्प्रोपोर्शनेशन नहीं किया हुआ पहले.
नहीं किया तो बड़ा, बस अब लिखें, इसीलिए मैंने डाउट के बेस पे करा रहा हूँ दोबारा इसको. मुझे ऐसा लग रहा था कि शायद मैंने पढ़ा दिया, लेकिन लिखें ये इस जगह भी आता है। एक्चुअली ये रिएक्शन इसी जगह फिट होता है क्लोरीन NaOH का हैलोजेंस में। तो डिस्प्रोपोर्शनेशन, अगेन एज आई सेड और रोड द डेफिनेशन अर्लियर, आप उसको हाईलाइट करके लिख लें। रिएक्शन इन विच वन एलिमेंट is reduced and oxidized simultaneously. So इस केस में when NaOH was cold, we get the sodium chlorate with +1 oxidation state. But when we take NaOH in hot state, like आप NaOH solution को heat कर दें, and then we pass chlorine gas from it. So it's like hot concentrated, at time written hot concentrated. Then even the reaction obviously would be faster because you're taking concentrated NaOH and you're heating it as well. Then our products are slightly different. It makes NaCl, NaClO3 and water. अब इसमें NaCl aqueous, NaClO3, sodium chlorate, इसको दोनों को हम sodium chlorate बोलते हैं. This is also sodium chlorate. The difference is कि chlorine's oxidation number in NaClO3 is +5. ये कैसे बनी, इसको सोचने की ये स्टेज थोड़ी लेट है. रिडॉक्स को रिवाइज करेंगे, उसमें मिलेगा आपको ये NaClO3 overall charge 0, sodium is +1 and chlorine अगर आप फाइंड कर रहे हैं तो oxygen is -6. So if I'm working out chlorine from here, I'll get +5 for chlorine. So NaClO3 में chlorine is +5 and NaCl में तो वो -1 है. So from 0 it goes to -1 and then from 0 it goes to +5. So we call it again disproportionation. अच्छा, इस
तो
इक्वेशन की
इक्वेशन बैलेंस कर दो।
ये मैं नहीं करूँगा, ये मैं कहने ही लगा था. आप लोगों ने इसको खुद बैलेंस करना है. ये when I teach it in face-to-face class, I make student balance this equation. इसको आप अभी कर लें या बाद में कर लें, आप लोगों ने करना है, क्योंकि this equation has come in past paper for you to construct and balance it as well. कोई मुश्किल नहीं. There might be 2, 3, 4, 5 numbers used. All right. I hope आपने लिख लिया. We can still do one more reaction. और अगर किसी ने बैलेंस कर लिया तो मुझे बताओ. नहीं हुई, कोई बात. DIY. अच्छा. देखिए, इनऑर्गेनिक को ग्रिप करने का, ऑर्गेनिक में तो मैंने आप लोगों को बताया है कि आप टेबल बनाएं, कन्वर्जन और वो सारा. बट इनऑर्गेनिक के लिए ग्रिप करने का एक ही मेथड है कि यू टेक 2, 3, 4 लूज पेजेस, लार्ज पेज ले लें रजिस्टर टाइप के, और जो रिएक्शन आप पढ़ रहे हैं ना उसको उधर लिखते जाएंगे, एक एक दो लाइन की स्पेस छोड़ के. So just write down the reactants and don't write products. Then just memorize all the equations, products and everything. उन pages की 2-3 copies करा लें और फिर उनके products fill करें पेंसिल से, उनके states लिखें, balance करें, कोई observation है साथ वो लिखें. This is one of the best practice for inorganic. और maybe मैं आप लोगों को एग्जाम से पहले कुछ दे दूं ऐसा चीज, लेकिन खुद बनाएंगे तो उसका फायदा है. So नंबरिंग में 4th नंबर पे अगर हम कर लें इसको, हाइड्रोजन रिएक्शन, फिर वाटर से रिएक्शन, फिर 3rd नंबर पे हमने क्लोरीन NaOH रिएक्शन कर लिया, एंड 4th नंबर पे दिस इज एक्चुअली द रिएक्शन ऑफ हैलाइडाइन टेस्ट. इसको इसी तरह हम लिखते हैं, टेस्ट ऑफ हैलाइडाइंस. ये टेस्ट आपके IGCSE के सिलेबस से चल रहा है. सो आई विल मेक इट बिट फास्ट क्योंकि इसमें एक आध चीज एडिशनल बताने वाली है, बाकी सब वो लेवल से है. तो मेरी लाइन सीधी हो जाए तो फिर आगे काम चलेगा. Here we go. So it's like 1, 2, 3 columns. Along with that halogen को मिला के 4 columns और 4 rows ही बनेंगी in fact. So it would be chloride ion, bromide ion, and iodide ion. These are the 3 ions that you're supposed to know as per syllabus test of halide ions. As I said, it's linked to IGCSE. तो मुझे बताएं if I've got a chloride ion solution there, कोई भी chloride ion का solution, NaCl, etc. or whatever, and I'm supposed to confirm के does it have chloride ion, so what do we put it into the solution? कौन सा reagent डालेंगे?
Silver nitrate.
फिर बताओ.
Silver nitrate.
Silver nitrate डालेंगे. We'll put AgNO3 into it solution. So silver nitrate is used to confirm presence of these reagents, 3 halide ions. अब हमारे A level के syllabus में कुछ additional detail है, वो ये कि if we put these precipitates which we form in dilute ammonia solution and concentrated ammonia solution, so what happens to the precipitates? So when we put AgNO3 in chloride ion solution, so we get precipitates. Could you tell me the color of precipitates formed here?
White.
White precipitate. इधर आपने लिखना है ना white PPT. And the formula of the white precipitate would be AgCl. With bromide ion, we get cream color precipitate, soft white or green PPT. And with iodide, we get yellow precipitate. And again, the formula with these precipitates will change. AgCl की जगह it will be simply AgBr, AgI. ये insoluble halides हैं silver के. Now, when we put these precipitates in ammonia, तो ये dilute ammonia और concentrated का effect है on precipitates, effect on PPT. मतलब ये जो PPT बने हैं ना इधर ये वाले, अगर इन PPT को मैंने ammonia solution में डाल दूं निकाल के यहाँ से, if I have a test tube and that has ammonia solution in it, we just need to see what happens to these precipitates, would it dissolve or not. So with chloride, the white PPT soluble, PPT dissolve. तो अगर dilute में soluble तो concentrated में surely soluble. इधर भी PPT dissolves. With green PPT, dilute ammonia में partially soluble, or sometimes they say insoluble. Like आधा dissolve हो जाती है बाकी नहीं. Concentrated से PPT dissolve. Bromide का. Yellow PPT of silver iodide are insoluble in both concentrated or dilute ammonia. तो ये जो प्रेसिपिटेट बने थे यहाँ पर सिल्वर नाइट्रेट से, इनको हमने we put it in ammonia, concentrated or dilute, and we see what happens to the precipitate. Chloride के PPT soluble in both, bromide के concentrated में soluble, dilute में partially soluble, and iodide के insoluble. Now based on these observations that I've written on the table, आप लोग मुझे बता सकते हैं कि if you are asked to comment on the solubility of precipitates down the group, मतलब ये जो precipitates हैं इनकी solubility कैसे change हो रही है, increase हो रही है, decrease?
Decreases.
Yes,
Decrease.
decrease हो रही है. So solubility of precipitates of halide decreases down the group. अब आयोडाइड के बाद एस्टेटीन है. अगेन एस्टेटीन हमारे सिलेबस में नहीं है, बट दे एक्सपेक्ट यू टू नो कि अगर एस्टेटाइड के पीपीटीज हुए तो वो भी इधर इनसॉल्युबल रहेंगे. ठीक है, I'll just let it out. अच्छा, there is another question that they ask you and they say कि comment on the color of precipitates down the group. ये जो कलर बना था पीपीटीज का, इस पे कमेंट करें down the group.
Darker down the group.
Yes, तो the precipitates color becomes darker down the group, from white, cream, yellow हो रहा है. तो पीपीटी gets dark और color dark हो जाता है downwards or down the group. एक लास्ट पॉइंट इसमें जो आपको याद ही रखना पड़ेगा, वो A2 के सिलेबस से है, बट MCQs में आता है इसमें. Wherever the PPTs are soluble, यहाँ पे dissolve हुआ, इधर हुआ, इधर हुआ, तो the precipitate dissolve to form a complex ion, और complex ion का फॉर्मूला होता है AgNH3 twice. ये बेटा आपने याद ही रखना है क्योंकि complexes A2 के syllabus में and they simply expect you to know okay what forms when PPT dissolves. When PPT dissolves, the solution will have a complex sign which is AgNH3 twice. मतलब chlorine हट जाता है PPT से and ammonia comes in its place. So it's just the last minute, but this reaction is extremely important because it links your row level IGCSE concept. ये silver nitrate वाली जो बात है और जो extra बात है बीच में ammonia के साथ PPT का behavior. That is additional and they ask you these things in MCQs a lot. इसको रट के याद करके तो फिर क्वेश्चन करेंगे तो we'll find them easy. अब ये बिल्कुल लास्ट मिनट है. I'll simply leave it for the question. अगर कोई है पूछ लें. I'll just share the recording in 5-10 minutes maybe. नेक्स्ट वीक में आप लोगों ने अपने इनऑर्गेनिक के नोट्स मुझे चेक कराने हैं. ठीक है सब लोगों ने. अभी चूंकि हमारा बिल्कुल कंप्लीट हो रही है इनऑर्गेनिक तो आई थिंक नाउ आई कैन आस्क फॉर दैट.
Okay, sir.
ठीक है जी. चलो दैट वुड बी ऑल देन. अल्लाह हाफिज़.
Allah Hafiz, sir.
अल्लाह हाफिज़.
Officer.
जी अल्लाह हाफिज़.